hyperbola, it's gonna have two curves in it. We're gonna be talking a lot about asymptotes. Do we remember what an asymptote is?
Isn't it a line that
Is that
the hyperbola approaches but doesn't touch?
Correctamundo. You approach it but never touch it.
yeah, awesome.
I don't know what you were drawing. What does the hyperbola equation look very much alike that we've already done?
The ellipse.
What's different between the hyperbola and the ellipse?
Subtraction.
Subtraction. Okay, so yesterday when we did the ellipse, we had x squared over a squared plus y squared over b squared. And it's still equal to 1, like the ellipse does. So the out of the circle, the ellipse and the hyperbola, the circle is equal to r squared. It's its radius squared. Ellipse and hyperbola are both equal to 1. And if they're not, like we did yesterday, we gotta set them equal to 1. Alright, so with that stuff that you're copying down, first thing you got is just your parent function like we normally do. Then that equation that says y equals plus or minus b over ax, let me write that up there, I didn't label. That would actually be the equation for the asymptote. I do this a little bit different, so I don't use that, but it might be handy for you to know. I'll show you how I do it, and we'll see. And then the vertices are over there just like they were for the ellipse. Okay? So let's look at ones. They're pretty simple. Always like, I don't know about that.
When you write asymptote for?
That's the, that equation, that's the equation for the asymptote. But I don't, you can do it that way, but I don't.
Okay.
But I just wanted to offer it to you, because you know, there's always more than one way to skin a cat. Alright, so let's look at 25y squared minus 4x squared is equal to 100. We want to graph that.
Hey, we did this one yesterday.
Yeah, we had something very, very similar to this on an ellipse yesterday.
Was it less than 7?
Yes. And I think the x and the y were flipped as well.
Would it
Ah.
be the same answer?
No,
Okay.
our answer's gonna be a graph. So an ellipse and a hyperbola don't look anything alike. So what do we gotta do first?
Divide by 100.
Gotta get it set equal to 1, so we're gonna divide by 100, just like we did yesterday. Divide one side by 100, you gotta divide everything by 100, so 25y squared over 100. What does 25 over 100 reduce to? 1/4, so that would be 1y squared over 4 minus 4x squared over 100. What does 4 over 100 reduce to?
122.
So 1x squared over 25 is equal to 1. Okay? So we need, what's my A?
2.
4.
A squared's 4, so A
Oh,
is
so
2. So we're gonna have, everybody see where Christian and Tyler came up with that? I got it backwards, didn't I? Yep. Cause on the y squared it's,
Oh, this is first.
yeah, on the y squared it's 0A. Alright, so if I start my process for graphing this, oh, I gotta get a white, change it to white. Alright, so first thing I'm gonna do is we'll find those 2 points on the graph. So I'm gonna go over 0 and up 2. Then I'm gonna go over 0 and down 2. So we've got a pretty good idea of what our hyperbola is gonna look like. I mean, because I showed you those examples on the opening screen, so it's gonna go have a curve there and have a curve there, right? Because it's vertical and right. Okay, so what I like to do to get my asymptotes is I'm gonna graph a box. And then in that box, I'm gonna draw the diagonals of the box, and that will be my asymptotes. Okay, so to finish out my box here, what is my, B right here?
Negative
Five.
5 and negative 5, right? So I could go right 5. This is not actually part of my hyperbola, this is just helping me draw it.
Well, I'll say negative because there's a negative before it.
Yeah, but
Oh,
I understand what you're saying, but
did
we're,
the big one first.
right. Okay, so I can extend here now and draw a rectangle. Do you see that? How I can extend that and draw a rectangle? Let's see if I can just draw a dashed one, because it's not actually part of my graph, so, where's my mouse? There it is. So drawing the box for me, so this rectangle takes the place of using that equation that they gave us earlier, because I'm gonna put the diagonals through that rectangle, and those are my asymptotes. The diagonals will cut straight through the origin and straight through those corners. Okay, so a lot of dotted lines going on in it. Okay, so now, all of that, just to bind those curves, because we know the asymptote is what we approach but never touch, so it's gonna go really wide out towards that diagonal and start curving up as it climbs, and same thing over here. So, just, are y'all good? Christian, you all right? That was weird, what was that?
So that,
Huh?
there's a weird speaker in this speaker.
Oh,
You click it, man.
okay.
You got that?
You're so funny, Christian. So those two curves that are not dotted is the hyperbola. All that dotted stuff was just my guide to get it.
So it doesn't touch the,
No, it will not touch. The only thing it hits is the, those points that we graphed first. Crazy kinda, but not very difficult. How did we make our box?
A and B.
we got the other
Just-
2 points and
Mm-hmm.
made it.
Yep, just used our A and B and extended the rectangle a little bit. So let's try another one. Let's do x squared over 16 minus y squared over 49. We're already equal to 1 this time, so we don't even have to do that. Alright, so is this horizontal or vertical?
Horizontal.
Okay, and Tyler pointed that out on the first one that we graphed. We get that by whichever, I wanna say by whichever variable is first, but it's, if you're, I'll just say whichever variable's first. If it's x squared first, x squared minus first, then it's gonna be horizontal, cause x is the horizontal axis. It really has more to do with the minus sign though, but,
So whichever variable has the minus sign, you got that.
well, that would make it be the opposite, which is gonna confuse you. Yeah.
Well, a lot of things.
Alright, so if we're horizontal, what is our curve gonna look like? Okay, so it's gonna go point to the sides. So what's my A gonna be here?
4.
So I'm gonna go 4, 0. See, last time we went
Yeah.
up and down because it was a vertical one, right? Holly, you got that? You're looking at me funny.
I was confused on how you got the 4.
The square root of 16.
Okay.
So we got those points there at 40 and negative 40. Now I can use the B, which is 7, to finish my rectangle. So I'm gonna go up 7 and down 7.
It's almost a perfect square.
Okay, so let me draw my rectangle. Okay, once I've got my rectangle drawn, then I'm gonna cut my diagonals through it.
That's what we're doing tomorrow.
Well, my original assignment tomorrow had circles, ellipses, and hyperbolas all together, but I'm not sure now.
You should give us a free.
I've been mulling that around, so I'll, what he said. Alright, so finally now, all that hard work to draw those dotted lines, I now am ready to draw the real graph. So, still see my points there, make them a little bigger so people in the video can see them. Still see my points there. Don't touch the dotted lines and curve away. So the snake crawling up through there. Ooh, got close. Okay. You ready to try one? Of course you are. Alrighty, you're gonna try y squared over 36 minus x squared is equal to 1. So, questions for you first off, is it vertical or horizontal?
Vertical.
It's vertical. What's the underneath the x squared?
One.
Not.
1. X squared is the same as x squared over 1. Okay, so try that. a soccer game today?
Yes, ma'am.
It's here?
Mm-hmm. Versus Barside.
Girls are outside.
So, just whenever the girls finish.
Mm-hmm. If they have overtime, extra time, I think it's good.
Sure would suck if they need the overtime.
Mm-hmm.
They don't just do like penalty kicks or something?
Well, I'm pretty sure it's, if you're tied up at the end of the game, you add like 20 extra minutes to the clock or something.
That's a lot.
Well,
How long is a half?
2 40-minute halves
Well,
for a normal game.
yeah,
And then I think once you get like a certain amount of overtime, you get a
penalty
free
kick.
kicks. Free kicks or penalty kicks.
What is a free kick? Get the goal open?
Well, the free kick is you're outside.
One-on-one kicker and goal.
Well, what's the difference between that and the?
Well, the penalty kick is you're 12 yards away from the goal, and it's just kicker goalie.
Oh,
And a free kick is you have a wall of
yeah,
people
and like three
that
dudes.
try and block the ball as well. You can also have more. Like I know for Messi's, they have an entire team.
What are you laughing at? Christian? You maybe have to come over there and get your electronic device. Be like, you were 2 weeks ago. Alright. Erased all my dotted lines this time just cause I wanted you to, that one was kinda overwhelming, but it was all scrunched in there together, so took the dotted lines away, doesn't look like much is up there at all. So, everybody alright on that? Not too difficult, not very hard, just something you gotta be able to do every now and then. So, for tomorrow on your virtual day, like I was telling Tyler, I did the assignment that I have I've already put it, I haven't pushed the button for you to see it, but I already have it in the Google Classroom. It's circles, ellipses, and hyperbolas all together, but I'm debating it, so we'll see.
We debate that.
We'll see.
Totally give us a free day.
Every day's free.
Well,
If it wasn't, I would be a millionaire.